video is for those who are writing 2026 WAEC Alternative B Practical Chemistry. In this episode, I am going to help you build a befitting titration table. But I'm going to do this from the white paper, that is from the specimen paper, and also from the redox equation drawn from the reagents given, molar concentration of the reagents, and the pipette volume you are using in your school. So stay tuned as we go into it. From the specimen paper, D and E are the titration reagents used. This titration is not acid-base, unlike that of alternative A. In the specimen, we have D and E, and the teacher is expected to prepare 6.30 grams of D, which is ethane dioic acid dihydrate, per dm cube of solution. So the teacher is expected to dissolve this gram inside 1000 cm cube or 1 dm cube of solution. The teacher is also expected to dissolve 3.10 gram of potassium permanganate inside 1000 cm cube. So there are two reagents, ethane dioic acid dihydrate and potassium permanganate. And the reaction of these two is not an acid-base reaction, it is a redox reaction because potassium permanganate is the oxidizing agent, while ethane dioic acid dihydrate is the reducing agent. This is a redox reaction. So for you to get your average titer and the befitting titration table, you must write the balanced redox equation of these two reagents. And from these masses given, you must calculate the molar concentration of the two reagents, that is D and E. And then the pipette volume you are using in your school is also instrumental to the calculation of your average titer and your tabulation. So let's get into it. We are going to first of all write the redox reaction. This reaction is going to be ionic. We are going to focus on the actual ions that are reacting. In potassium permanganate, the ion that is reacting is permanganate ion, KMnO₄ 1-. It is going to react with oxalic ion or dioate ion, which is this C2O4 2-. And then during the titration, you will be asked to acidify this system because the reaction takes place in acid medium. So H+ from acid is required. And then the product is going to be from permanganate ion to manganese 2 ion, Mn2+, plus carbon 4 oxide plus water. And for the equation to be balanced, we have 2 here, 2 here, 5 here, 10 here, and 8 here, and 16 here. Now, the essence of balancing the equation is to get the mole ratio. So the mole ratio is 2:5. The next is to calculate the molar concentration of D and E, because from the molar concentration, we will now find the average titer and the table if the pipette volume is constant. So this one is gone. Let's call this number 1, 2, 3, 4, 5. Number 2. We are going to calculate the molar concentration of D first by saying that molar concentration equals mass concentration over molar mass. Remember, what we are facing is H2C2O4.2H2O. So molar concentration equals mass concentration, and you know that the mass concentration is 6.30 grams. So you write 6.30 over molar mass. Molar mass is the formula mass, so you can write the formula in the meantime. 6.30 over the atomic mass of hydrogen is 1 times 2 plus atomic mass of carbon 12 times 2 plus atomic mass of oxygen 16 times 4 plus 2 times molecular mass of water, which is 18. We have 6.30 divided by 2 plus 24 plus 64 plus 36. We are going to have 6.30 over, so we have 126 here. And we are going to get 0.05. So 3 significant figures, 0, 0, mole per dm cube. Remember, this is the molar concentration of D. Number 3, molar concentration of E. Remember, E is potassium permanganate, and the mass concentration is 3.10 grams. 3.10 grams over formula mass, which is KMnO₄. What we have is 3.10 over atomic mass of potassium is 39. Atomic mass of manganese is 55. Atomic mass of oxygen is 16 times 4. And we have 3.10 divided by 158. If you divide the two, you will get 0.0196 mole per dm³. This is the concentration of E in mole per dm³. Now take your screenshots as we move into pipette volume, average titer, and titration table. So note that molar concentration of D is 0.0500 mole per dm³, and molar concentration of E is 0.0196 mole per dm³. So we move straight to average titer, noting that the pipette volume may be 20 cm³ or 25 cm³. So bearing in mind that pipette volume in your school is 25 cm³. Please, if the pipette volume in your school is 20 cm³, continue with 20 cm³. Don't use 25, but I'm using 25 for the purpose of this class. In this alternative B, D is ethane dioic acid, which will be in the pipette, right? E is potassium permanganate, which will be in the burette, which means you mention the reagent that will be in the burette first, which is E, before the one in the pipette, which is D. CeVe over CdVd equals Ne over Nd. Our E is potassium permanganate, which is the oxidizing agent that should be in the burette. And our D is the oxalic acid or ethane dioic acid that should be in the pipette. The average volume of E is the average titer, and that is what we have to calculate. Ce is a concentration, molar concentration of E, which we got as 0.0196 times Ve we are yet to calculate, divided by Cd, concentration of the ethane dioic acid, which is 0.0500, times Vd, volume of ethane dioic acid, which is the pipette volume, right? 25 equals Ne over Nd. This is the E and this is the D. So we have 2:5. 2 over 5. 0.0196 times Ve times 5 will give you 0.098 Ve equals 0.05 times 2 will give you 0.1. 0.1 times 25 will give you 2.5. If you divide both sides by 0.098, you are going to get Ve, average titer, as 2.5 divided by 0.098, and that is 25.5 cm³. So this is the average titer in your titration. Now, the next is to build the titration table. But before that, this is a theoretical value. You must not use this exactly. You can use the range from 26.00 to, let's say, 29.00. Anyone can go 26 to 29. So let us build our table with something closer to this. Let's say 26.00 cm³. And to do that, you need to make sure that all the titer values are concordant, and also that this value is also concordant with the titer value of the teacher. If you are the teacher watching this, it's assumed that you may use this, which means in building the numerous titration tables for your kids, you must make sure that their titer values are concordant with themselves, with the difference of maximum of 0.2, and also concordant with this. So to do that, we will build a titration table that looks like this. I will encourage you to use 0.00 throughout as your initial. Please maintain 2 decimal places. If you are using 1 decimal place, maintain it too. Don't mix the two because you'll be penalized. Now, since this is our average titer, you can remove 0.1 from here and you are going to get 25.90. That is your final burette reading. After running your titration, this is the final burette reading that oxidized the reducing agent. And if you minus 0 from here, you get the same thing. If you add that 0.1 here, you will get 26. So you write 26.00 minus 0, 26.00. Add that 0.1 to 26, you will get 26.10 and then 26.10. Now you can see that the average volume of E will correspond to this. And we have 25.90 plus 26.00 plus 26.10 divided by 3. you are going to get 78.00 over 3, and it will give you 26.00 cm3. I hope you got value. Now share this video as wide as possible and wait for the next episode, which is on salt analysis for the 2026 alternative B. Do have a wonderful day. Bye.